Let's calculate resultant values using exponential growth and decay models. It's a fun time here today. So let's kind of talk through these. They're all kind of the same, but they look maybe a little different. So our basic exponential function is f of x equals ab to the x. And that's different than if we talk about exponential growth and decay over time, where growth would be a sub t equals a times 1 plus r to the t. And you might say, well, that's the same thing, where b is the growth rate, right? 1 plus the rate of growth. And then decay would be a at 1 minus r, because if it's decaying, it's going down, where t is time. So this is over time. So if something is decaying per hour, per day, or something like that. Now the difference is continuous compounding, or this could be continuous decay. So it could be growing or decaying, but if it's continuous, we're going to be dealing with a sub t equals pe to the rt. You might also see this as a sub t equals a sub 0 e to the rt, where a sub 0 just means the initial amount, right, which is the same as p. You could also see this as a sub t equals a sub 0 e to the kt. So some people say I use r if I'm talking about money, like interest rates. So they use r. And if they're talking about anything else, maybe the population growth, if it's not money, they use a k to represent the percent of increase. But the deal is, either way, whether it's a K or an R, it's the rate of increase or the rate of decrease if we're talking about decay. That's kind of the big piece. So we'll talk about these. We're going to do a growth and a decay problem. I use R for everything because to me it's just easier to stay consistent. But if you see a K, it means the exact same thing. Okay, a new gardener added a fertilizer with a potency of 200. The bag says it decays at a rate of 3% per day, and reapplication should occur when the potency falls below 15. What is the potency after 30 days? And one thing that we should add is that this, no, we shouldn't. Okay, so because it says decays at a rate of 3% per day, this is by time, so we are using the formula a sub t equals a 1 minus the rate raised to the time, because we have a time period. It's not continuous, it's by time. Plug in what we know. My initial amount is 200. My rate of decay is 3%. Always change percent to a decimal to play with it. And we care about 30 days. My time is 30. So notice this falling below 15. That's not important here. We don't care. So now we do order of operations. Inside parentheses first. So 200. 1 minus 0.03 is 0.97 raised to the 30th power. Now we do exponent next. So 0.97 to the 30th power is going to give me 0.401070, and it goes on and on and on. Don't round in your calculator. Leave that answer with all of its decimal places and just multiply by 200. That will give us, after 30 days, right, the amount after 30 days equals 80.201, which rounds to the nearest whole number of 80. So the potency after 30 days will be 80. Let's do a growth. An investor deposits $15,000 in an account that grows continuously at 3% per year. How much will be in the account after 10 years? Round to the nearest cent. Okay, so we know we are growing continuously, so we are going to use the formula a sub t equals p e to the rt, because this is the continuous. All right, so plug in what we know. Beginning amount, 15,000. E, let's raise it to the rate, 3%, times the number of years, which is 10. It is important to do your exponent first. So 0.03 times 10 will give me an exponent of 0.3. Then we're going to take, right, we do the exponent next. So E raised to the 0.3 power is going to give us approximately 1.3498, goes on and on and on. Again, do not round in your calculator. Leave that number. Just hit times 15,000, and the time after 10 years, the amount after 10 years is going to be $20,247.88, rounded to the nearest penny. So you have to make sure with these questions that you're reading them carefully. Are you going continuously, or is it a per time period? That changes the formula you're going to use. So just make sure paying attention to the words, because details matter.